Everyone, my name is Zhu, and this is my DA5030 presentation. About the data is obtained from a website called cargo.com. It contains more than 50,000 League of Legends match data. I'm only use 10,000 of them, however, because using all the 50,000 is too much, and running each algorithm will take more than 10 minutes. This is not very efficient. The business problem is how to build a real-time winning rate predicting AI. As you may know, real-time winning rate predicting is a very popular topic in big mobile games like Dota 2 and League of Legends. So what I'm going to do here is predict the winning rate in a League of Legends game match given a set of in-game information such as which team take the first blood, which team take the first dragon, and extra. Explore the data. First, look what features are included in the data and their meanings and their values meanings. I can know this information clearly with the help of the information document contained together with the dataset. After exploring the data, I will select 6 interesting features and make histograms of them to have a brief overview of the value distribution of these interested features. Here is an example of an interested feature called first rift, and the value meaning is that 0 means that no team take the first rift before the game ends, and the 1 means that the first team take the first rift, and the 2 means that the second team take the first rift. Data transformation. Since I'm doing categorical data, so one very important transformation I need to do is dummy coding. I did dummy coding with the help of a library called fast dummies. It provides a function called dummy columns, which I can select multiple columns of the dataset and transform them into dummy code in one function, which is very convenient and fast. After transfer all the features into dummy code, I need to further transform them as factors because many categorical functions use factors as input value. So about the models, since I'm predicting which team is the winning team, given all the features, this process is mini classification. So I first choose from classification methods. Then since there are totally 6 features and 18 dummy features, I don't think it's very possible to get a linear model from all these features. So I select from nonlinear methods. So finally, I will choose SVM with nonlinear kernel, KNN, and the decision tree as the 3 methods I'm using. Here are the building process of each model. I choose 75% of total dataset as training data, and use these different libraries to get all the functions I need. Prediction. The predictions are done mainly use the predict function. The predicted result have many different formats that need to be taken into consideration before evaluation. For example, the KNN predict result has 2 columns containing the probability of being each category. So I need to first do a if-else function to select the higher probability and convert the format into the same format as the predicted feature, which is on in the category. About the model performance, since it's categorical data, so accuracy is a very basic and important feature for categorical data. Apart from accuracy, I also use AUC to help me get a better understanding of the evaluation. I used 25% of the data as test data, and I also use a five-fold cross-validation to help evaluate the result. In this form, the first three columns are done without cross-validation, and the right three columns are done with a five-fold cross-validation. As you can see here, the best accuracy and AUC is achieved with the SVM with cross-validation. But other models also have very high accuracy, around 90%. Ensemble model. I use a card stack function from card ensemble package to do the ensemble. The accuracy of the ensemble model is 0.89, which is slightly lower than the previous accuracies, but it's still very good, which is around 0.9. And the code I read is mainly about list all the methods I'm going to use in a algorithm list, and then do a train with this algorithm list. The key lessons I learned from this project is that first, CART is a very powerful library because basically all the prediction methods can be found in the CART train function, and it can also do cross-validation and model ensembling. So which means that you can basically do everything with this train function. The second lesson I learned is that it's very important to explore the data and find the interesting feature before doing the modeling. And actually, the dataset contains much more features than the interested one. I spent some time to select the interested one before I doing anything else. The third lesson is that find a trade-off between efficiency and accuracy. First, when I first got the data, I used all the 50,000 dataset as a training dataset, and then I found that each single algorithm will take more than 10 minutes to run, and although it may have better accuracy, but it will take much longer for me to complete this project, and not to mention with cross-validation, which will take even longer. So I use 10,000, which is not very a small number, but it help increase the efficiency a lot. So when I decrease the number of the dataset, each algorithm will take not more than 2 minutes to run, which is acceptable. That's all. Thank you.